Today I'll discuss about a perturbation problem where the potential consists x to the power 4 term. The calculation is very much rigorous, so you'll have to pause the video wherever necessary and try to solve it yourself. Here x operator can be written as root over h cut by 2 m omega a plus a dagger, where a is lowering operator, a dagger is the raising operator. We know to calculate the first order energy correction, I'll have to calculate Brian x to the power 4 and k10, and the constant term will be like this, h cat square by 4 m square omega square, and I'll have to calculate this one, a plus a dagger whole to the power 4. Here lies the original calculations. First, you will have to consider a plus a dagger whole to the power 4 as a plus a dagger the square into a plus a dagger the square, and this becomes this term, this becomes this term. So while multiplying this term with this term, this bracket with this bracket, we'll get 16 terms. But we know that Brian and K10 as there is two Brian and K10. If we multiply this term with this term, a, then this k term will be diminished in n minus 4, and Brian with get n minus 4 will give 0 as result. So in the multiplication term, only you will have to take that terms which consist of 2n to a dagger. This raising operator will increase the n value to n plus 1. This one will increase that to n plus 2. This a will decrease n plus 2 to n minus n plus 1. And this a will decrease that n plus 1 to n. So the resultant will be Brian and K10, and those terms will only exist. As we know that Brian with K other than n will give 0 as results. So while multiplicating the two terms within the parenthesis, we'll get 6 terms which consist of 2n to a dagger. The first will calculation will be like this. In the first step, this n will be root over n plus 1, and n become n plus 1 as a dagger, that is raising operator, is applied here. All others remaining the same. The next step, a dagger operation n plus 1, which becomes n plus 2, and will give root as root over n plus 2. As we know that a dagger of n equals to root over n plus 1 get n plus 1. That is the state raises by one step, and the root over consists of n plus 2, n plus 1 term. If we calculate this as, we'll get this term. Similarly, a dagger, if the operator is a dagger, that term will be like this. The solution will be like this, which contains n plus 1 the whole square. This term a dagger a will give n into n plus 1. This term a dagger will give n into n plus 1. The logic is the same. A dagger applies to n gives root over n plus 1 and get n plus 1. A operator works on n, get n. This gives root n, and the value of n becomes n minus 1 as a is the lowering operator. It lowers this state n to n minus 1. Similarly, if we calculate n a dagger a n, this becomes like this. This calculation will be like this. And this gives n square as values. n a dagger a n gives n into n minus 1. Adding all the 6 terms, we get this one, and which are after simplification gives 6n square plus 6n plus 3. The main logic of this problem lies in only one fact. That is, if raising operator a dagger operates on n, this gives n plus 1 root over into the state n raised to n plus 1. And when lowering operator a operates on n ket, that gives root n and lower the state n to n minus 1. This is the entire logic that has been discussed in the problem.